Okay, let f be a function defined by this piecewise function. We've got a trig function. When x is less than or equal to 0, we have a exponential function when it's greater than 0. This is calculator inactive. So let's see what part A says. Part A says show that f is continuous at x equals 0. So we're showing this process. Here's what we have to do. Remember, this is going way back. Okay, continuity. The left-handed limit has to equal the right-handed limit, and that value has to equal the value of the function at the x value we're talking about. So we need to evaluate the limit as x approaches 0 from the left. Well, that would be of 1 minus 2 sine of x. So that's equal to 1 minus 2 sine of 0. The sine of 0 is 0, so that's 1 minus 2 times 0, which is 1. The limit as x approaches 0 from the right is e to the negative 4 times 0. Whoops, sorry, I need my function notation right here. Then I can plug it in. The right side is the exponential function, so then we can plug it in. E to the 0 is, of course, 1, so that's good. Since the limit as x approaches 0 from the left of f of x equals the limit as x approaches 0 from the right of f of x, then the limit as x approaches 0 of f of x equals 1. I should have a 1 there as well. Okay? So that's the first part. Left-hand limit equals right-hand limit, so the limit, the two-sided limit of the function at 0 is 1. Then we need to find f of 0. Well, the equal to part was the first part of the function. So that's 1 minus 0, which is 1. Okay? So, therefore, f of x is continuous at x equals 0. Now, it's not necessarily continuous everywhere. This one is, actually, because both of those pieces are continuous everywhere. The question is, did they meet up at the right place? And they do. But all we have proven is that it's continuous at x equals 0. All right, part B. For x not equal to 0, express f prime of x as a piecewise defined function. Find the value of x for which the derivative equals negative 3. So if we're trying to find the derivative of our function here, we're just going to take the derivative of both pieces. Okay, so the derivative of the first piece, the derivative of 1 is 0. The derivative of negative 2 sine is negative 2 cosine of x. For x is less than 0. And the derivative of e to the negative 4x would be negative 4 e to the negative 4x. All right, so that's part 1 of it. We get 2 points for that derivative. So 1 point for the first part, 1 point for the second part. Then it says find the value of x for which the derivative equals negative 3. So that means we've got to plug each piece equal to negative 3. So divide both sides by negative 2. So we get cosine of x equals 3 halves. Is it possible for the cosine of an angle to equal 3 halves? 3 halves is 1.5. No, cosine cannot be greater than 1. So I don't really know. I'm just going to leave it there. Okay. I'm not going to write anything. I'll put a line for my equal sign. Okay. Over here, we can solve this one. So divide by 4, so we get 3/4. Our variables in the exponent, so we have to write this in log form. So the natural log of 3/4 is equal to -4 over x, or excuse me, -4x. So then we go through and divide by -4 or multiply by -1/4. And that is our value of x. You get 1 point for that part. That doesn't look like 1 point. Okay, let's look at part C, last part. Find the average value of f on the interval from -1 to 1. So average value 1 over b minus a times the integral from a to b of our function in question. So 1 minus -1 is +1, so that's 1/2. Now, if we are integrating this function from -1 to 1, we're going back to that piecewise function. We have to split it up into the pieces. So we've got the integral from -1 to 0 of the first piece, 1 minus 2 sine of x dx, plus the integral from 0 to 1 of our other part, e to the -4x dx. Okay, so we've still got this 1/2 in front of this whole thing. Anti-differentiate 1 minus 2 sine of x, so that's x plus 2 cosine of x, because the derivative of 2 cosine of x would be -2 sine of x. We're evaluating that from -1 to 0. The antiderivative of e to the -4x would be -1/4 e to the -4x, because if we take the derivative of that, the derivative of e to the -4x is -4 e to the -4x, so the -4 and the -1/4 cancel. And we're evaluating that piece from 0 to 1. So plug in the 0, so 0 plus 2 cosine of 0. Be very careful with your trig functions and values at 0. Minus -1 plus 2 cosine of -1. Plus -1/4 e to the -4 minus -1/4 e to the -4 times 0. So let's be very careful with this. Technically, as far as I know, that part right there, if you just left it right there, you would be fine. But I know that probably drives you as crazy as it drives me. So let's do some simplifying here. Obviously, that 0, the cosine of 0 is 1, so that next value is 2. We're subtracting a -1, so we add 1. We can't do anything with the cosine of -1 without a calculator, so we've just got to leave that as it is. Same thing with e to the -4. We can't really do anything with it without our calculator. And then e to the 0 is 1, so we're adding a 1/4 there, because we're subtracting a negative. Let's see here. We've got 2 plus 1, which is 3, and 3 plus 1/4 would be 13/4. And that's really as far as you can take it. I mean, they distributed the 1/2 on the rubric, but if you leave it in that factored form, I think you're fine. Oh, wait, they have a minus. What's that? Oh, I forgot to distribute that negative. Whoops. See, I would have messed up. Gotta be careful. I forgot to distribute my negative. That's why I always encourage you to either draw your little arrows or go ahead and change that sign. I was so focused on evaluating it that I overlooked that. So I would have lost a point. Okay, so you get 1 point for splitting up the integral right here into the two pieces and plugging in the appropriate function. You get 2 points for your antiderivative, so I'm assuming that's 1 point for each one. And then you get 1 point for your final answer right here. And again, any of those 3 lines, as far as I understand, are acceptable.